was by chance that sponge divers exploring off the Grecian island of Antikythera in 1900 came across one of the greatest maritime finds of the century, a Roman merchant ship from 60 to 80 BC. On board, amongst an impressive array of looted bronze statues and coins, was an unassuming lump of corroded bronze, soon found to contain an astronomical calculator far more advanced than anything thought possible in the time of its origin, 2nd century BC Greece. I'm Tom, and welcome to Physics Foundry. It was a few months after the artifacts were salvaged that the corroded bronze lump split in two, revealing a bronze gear wheel. This was particularly amazing because previously no metal gear wheels had been found from the classical era. By 1905, academics had realised that the device was an astronomical calculator, but just how complicated it was not really found out until the 1970s work of Derek de Soler-Price and others. By using X-rays to look inside the device, 30 gear wheels were found amongst the 7 largest fragments, and 81 further fragments were also found to contain sections of the device. These 30 gears all fit inside a cereal box-sized shape. This is all the more impressive when you consider that the 2 largest gears have 223 teeth, a prime number, so impossible to subdivide while cutting the teeth out, which is really impressive when you consider it was all done without modern equipment. The next step in the mechanism story began with the Antikythera Mechanism research project being set up in 2005. The project is led by astrophysicist Mike Edmonds, who is with me now to explain some more about the device. So, what first sparked your interest in the mechanism, and how did you get involved in the research project?
Well, I've always had an interest in the history of astronomy, and at Cardiff University we run projects for students in their final year. One year I had a very practical chap who wanted to do something in the history of astronomy, and I happened to have picked up a book about the history of engineering, and there was a diagram in there of this Antikythera mechanism.
Right.
So I thought, well, let's investigate what's known about that. And we spent a year looking at what was known about it and doing some predictions about whether it could have had planetary mechanisms in it. And in fact, it got written up as a review paper, and basically it snowballed from that.
What techniques did you intend to use to expand on the understanding that people already had?
Well, the main thing was that we knew that in order to make progress, we needed more data. The idea was to get data using modern techniques which weren't available to previous investigators.
Right.
In particular, to get very good surface imaging, and also X-ray CT, or computed tomography, which really means giving the thing a body scan in X-rays to get the internal structure.
What do we understand of what the mechanism can do at the moment?
I've made here a little sort of model. It's about 3/4 size.
Okay.
And on it I've put just the dials that we know were there. And on the front of the device here, there is a big double ring here, which would have had pointers going around it, which shows the zodiac. Those are the constellations in the sky through which the sun and the moon move during the year. Yeah. And as the moon moves around the sky during the year, we see it going through the sky every day because the Earth's turning. Yeah. But as well as that, there's a general motion through the year.
Okay.
And that's what gives you your birth sign, as it were, where the sun was when you were born. And this thing had a dial with the zodiac around it, and also a dial with the corresponding months on in the Egyptian calendar, in fact, which was often used by astronomers. And there'd have been a dial, pointers here to show the position of the sun, the position of the moon, also the phase of the moon. There was a little device with a half-silvered ball to show the phase of the moon. So you held the thing, and you turned a knob on the side to make it turn around. Yeah. And if you turned it round on the back here, there were more dials, rather complicated dials, as you can see, these spiral dials. The top one showed something which was called the metonic cycle. It has to do with how you fit the number of lunar months into a year. Okay. And it turns out that you can fit just about 235 lunar months, full moon to full moon, into exactly 19 years around the sun. Okay. And that's what it shows. It shows 235 months of that lunar cycle. That's very useful for setting up your calendar. On the bottom here, there was another dial, Saros dial. This had 223 divisions on it. And you had a pointer here that moved around during that about 18.2 years that tells you when there is a likelihood that a lunar or solar eclipse might appear. Done on the basis, we believe, that they had records of ancient eclipses, and there was an eclipse cycle which was known to the Babylonians, that if you have an eclipse at a particular time on a particular moon, then 223 months later, there's an almost exactly similar eclipse. Also on the back here, There are two little dials. This one has to do with eclipses. It's called the ectiligmos cycle. It has to do with how, again, these cycles repeat. This little one at the top here, this little quadrant dial here, is very interesting because, much to our surprise, it turned out to show the year in which particular Pan-Hellenic, that's across the Greek world, athletic games should be held.
Oh, right. So
it had actually had the Olympic Games marked on here as one of those games. It may have been partly to orient yourself to make sure you knew which year you were in. Calendars were very uncertain in those days. They varied all the way across the Greek world. It may have been knowing which year you were in relative to the games, sort of anchored you, as it were, to know which year you were talking about.
Yeah.
Okay, well, what I've got here is some replicas, full size, of the bits, the main bits of the mechanism that remain. There are about 82 of them, but some of them are very small. This is the classic one that you see in most things, with a wonderful thing I call the chariot wheel on the front, gear wheels visible, and also the remnants of the various scales. Here's another of the little fragments, again showing these scientific scales, and that bit is a bit of one of these back dials.
Right.
And here is another little fragment that exists. That's a little bit of this front dial here showing the zodiac signs. A great deal of the information which is in this mechanism comes to the Greek world from Babylon.
Right.
Babylonians were very great observers, and it's from that information collected over hundreds of years that they systematized and gave rise to the knowledge of the cycles, which was incorporated in this mechanism by the Greeks. Now, going back to this front dial here, almost certainly there was a display of the position of the planets. We believe that's true because a lot of the script, the actual mechanism is covered all over, all around here on front doors and a back door.
Right.
There was Greek writing. They mention all the names of the classical planets and also what are called stationary points, which is when a planet moves across the sky, stops, moves back again, and so on. So there's very good reason to believe that they did in fact have the planetary motion displayed. Unfortunately, that bit of the mechanism is lost. It's still presumably lying at the bottom of the sea somewhere.
Yeah.
And there would have been some arrangement to give, probably on this front dial here, some indication of where the planets were in the sky.
Obviously, this is a lot more advanced than any devices that have been found other than this. So how does it fit into what the ancients understood about the planets?
Yeah, it's the most complicated device to have been found until the era of the medieval cathedral clocks. One interesting thing, if you look back in the literature in classical times, there are mentions of devices like this.
Okay.
We know also the Greeks were interested in things like automata and sort of theatre, model theatres that moved and so on. There's no doubt from the literature that there was a long tradition of building these things. So, although it's surprising to us to find this nowadays, I think it's because we've forgotten just how sophisticated the Greeks were. What happened after this is a very interesting thing. Why did that technology sleep for another 1,000 years?
So having found out all of this, what are your hopes now?
Well, there's still some things to do. All the inscriptions on the mechanism have got to be published. Most of the information, I think, has now come out from the machine. We really need another one, preferably with a planetary mechanism, if you can manage it, to take the study further. There's still a lot can be done, probably in tracing what happened afterwards. And if in the Arabic world we could find some more artifacts that are daughters or the succession of what happened to this until that technology reappeared as clocks.
Okay. Well, that's all really, really interesting. So thank you for coming and talk to us. Any comments, questions or suggestions, feel free to leave them in the comment section below or on Twitter. And be sure to check us out on Tumblr and Facebook for more cool science.